Greetings and namaskar to each one who came here to watch this video. Topic of today's video is LED, that is light emitting diode. Well, this is a very common topic. In this video, we are going to cover the topics like optoelectronics, then the introduction of the LED, its history, then its symbol and its circuit, then its working, then about the color and material of the LED, then types of LEDs, then its applications, and then advantages and disadvantages, and we'll end up with the conclusion. So let's start. Well, we all know that LED is a light. So today, LEDs are rapidly phasing out of incandescent and fluorescent light bulbs. How? So you all know that these are the two most used bulbs in the history. But now as LEDs are here, it has overcome these two bulbs. How? They are superior in the brightness, lifespan and energy efficiency, made them a learning for both commercial and residential uses. LEDs have more brightness and their lifespan is also more than these two types of bulbs. Moreover, it is more efficient. That is why it is in great use in both commercial and residential sectors. Well, the fact that LED are only getting less expensive over time further adds their desirability. In next decades or so, justifying these both bulbs over LEDs could become difficult. So now, from which branch LED came from? So that is optoelectronics. This word is a combined form of optics and electronics. Optics is obviously related to light and electronics is related to electricity. So this branch is the study of the combination of optics and electronics, that is light and electricity. And all the devices which are based on this technology are known as optoelectronic devices. These devices includes emitters, sensors, autocouplers, auto-isolators, etc. In this chart, the categories of the optoelectronics. So the devices that can detect the optical signals through the electronic processes such as photodetectors, and the second category is the devices that detect optical radiation into the electrical, for example that is solar cell, and the devices that detect electrical energy into optical energy, that are emitters. Here comes the LED and the laser. So from here we can see that LEDs are something that we are getting from the conversion of the electrical energy into the optical energy. So let's start with the introduction part. So LED is a short form of light emitting diode. It is an PN junction diode. What is PN junction? It is a mixture of the semiconductors P-type and N-type. P-type contains holes and N-type contains electrons. So LED is simply a PN junction diode. So now what happened? LED emits light when activated by a suitable voltages applied to the leads, or we can say a semiconductor diode that glows when a voltage is applied. So how it works? When we apply the voltage, that semiconductor device will emit light, and that is known as LED. So what basically happening here is the conversion of the electrical energy into light energy, as we are supplying the voltage, and as a result we are getting the light. The LED photon emission is due to the spontaneous transition of the electron from conduction band to the valence band, resulting in a fairly wide spectral output bandwidth. As you can see here in the diagram, a emitted photon. This is happening by the transition of the electrons from the conduction band to the valence band. The electrons are losing energy, they are releasing energy in the form of light. Light is obviously a form of photon, that is h mu. This is very basic how we get light from a semiconductor. Now just talking about the history. Started in 1907, H.J. Round firstly discovered the electroluminescence. This is a phenomena, simply the generation of the photon by the recombination process. That is the basic principle of the LED. This concept was first introduced in 1907. And then further in 1920, LED in radio sets was studied. Later on, the infrared LED, which is known as the first modern LED, it was developed in 1961, and the first visible light, that is red light, and then the first LED light was developed in 1962, and then the violet LED, and the facial high brightness LEDs were developed in 1976 and so on. This basically took a lot of years, as you can see, from 1907 to 1976. A lot of physicians worked over it and helped us in making our life better. So now moving to the symbol and the circuit of the LED. Its symbol is as it is of the diode. As you can see in the diagram, there is a slight change, and that is of two arrows which are pointing outwards from the diode, and that is showing the emission of the light. So the LED symbol is the standard symbol for a diode, with the addition of the two small arrows denoting the emission of the light. The P side is the anode, the N side is the cathode, and the light is emitting from this PN junction diode. And here you can see how we use LED in the simple circuit with a battery, resistor and wires. That's it. Now moving to the LED. The best known of all optoelectronic devices is the LED, light emitting diode, which emit a fairly narrow bandwidth of visible or invisible light when its internal diode junction is stimulated by a forward electrical current, voltage or power. As we discussed previously, when we supply some voltage or electric current, this diode emits light, and the light may be visible or invisible, visible in different colors and invisible as infrared. Well, this LED works on a forward biased. LEDs have typical power to light energy conversion efficiency some 10 to 50 times greater than a simple tungsten lamp, and have very fast response time, and are thus widely employed as visual indicators and as moving light displays. So as we already know that in LEDs, power, that is electrical energy, is converting into light energy. And this is such a quick process, and this is how it is easily overtaking the tungsten lamps, which were used to get heat up first and then they used to emit light, which is really a lengthy process. And here in case of LEDs, they are so quick at responding that we can easily use them as indicators. Now let's see how LED works. Now let's understand this diagram first. What simply happens when electrons get energy, they jump from lower energy levels to the higher energy level. So they absorb some energy and they jump from lowest energy state to the higher energy state. Now after some time, obviously the electron from higher energy state will come back to the lower energy state, and during this process they will lose some energy, and that energy that electron are losing are in form of either heat or light. So this process, electron again coming back to their original state, or we can say a recombination process is happening, then they release energy. So this is what is happening over here in the working process of LED. Suitable voltage is applied across this PN junction diode, an electric field is generated, and the electrons from the conduction band falling down in the valence band. Already know valence band is full of holes and conduction band is full of electrons, and this is P and N type. Valence bands are P type and conduction band are N type semiconductors. So as we give a suitable voltage, then electrons and holes from conduction band and from the valence band starts recombining. Each recombination of the charge carriers will emit energy in the form of heat or light, and then the semiconductor glows, which acts as LED. So now let's go through its theory. Working principle of LED. The operation of light emitting diode is based on the phenomenon of electroluminescence. What is electroluminescence? It is generation of photons as a result of recombination process, which is the emission of light from semiconductor under the influence of electric field. Recombination of charge carriers take place in forward PN junction. As the electron crosses the N region, recombine with the holes existing in the P region. Electrons are in the conduction band of energy level, while holes are in the valence energy band. So what it is saying? A process is happening, emission of light is taking place from the semiconductor when it is under the electric field, and there is Recombination of charge carriers. What are the charge carriers? That are electrons and holes. Electrons with negative charge and holes with positive charge. So they are recombining in the forward p-n junction. Means the current is flowing from p-type to n-type. Electrons from n-type started combining with the holes from p region. Therefore, the electrons are at high energy levels than the holes that are in the low energy levels. For the electrons to recombine with holes, they must give some of their energy. Typically, these electrons give up energy in the form of heat or light. As I told you, when the recombination process takes place, they release some energy, and that energy can be either in the form of heat or light. So, let's understand why we are using forward bias here in the LED, and also how do we get light. In silicon and germanium diodes, most of the electrons give up energy in the form of heat. So when the recombination process takes place in either silicon or germanium, then they will emit heat. But when we use compound semiconductors, that is the combination of the semiconductors, then the energy emitting through that combination will give us the light energy. So with semiconductors like gallium phosphide, etc. semiconductors, electrons give up the energy by emitting photon, that is light. Now, if the semiconductor is translucent, then the light will be emitted and the junction will become the source of light. What is translucent? It is half transparent and half opaque. If we are using such type of material over semiconductor, then light will emit. That junction will act as source of light, that is what we call LED. LEDs emit no light when they are in reverse biased. Why? As no recombination will take place in reverse biased. In fact, the LEDs in reverse bias mode will quickly destroy them. Therefore, LEDs work only in the forward biased. Now, as you must have seen the LEDs in Diwali decoration, we see different colors of light. Have you ever thought how we get different colors of light? So now we are here with the answer of this question also, that what determines the color of LED? The color of LED is determined by the material used in the semiconductor element. The two primary materials that are used in LEDs are gallium indium phosphide. These alloys are used to obtain different colors such as red, orange, yellow light, etc. Whereas indium alloys are used to get green, blue and white light. Light changes in the composition of these alloys changes the colors of the emitted light. You must have seen the LEDs have domed shape lenses over it. What is the reason of this domed shape? So its reason is to reduce the reabsorption problem. What does it mean? Maximum reflection with minimum reabsorption. LEDs are always encased in order to protect their delicate wire. As you can see in the table of materials of choices, by applying different forward voltages and combining different semiconductor, we will get different colors of light. So, LED can be manufactured to produce light of virtually any color. So, two aspects are there that are affecting the color of the light is the material used and the voltage given to the semiconductor diode, which is working in forward bias. Now, the LEDs that are used in the AC circuits as an indicator, so they are applied parallel to the normal diode but in the inverse direction. So we can say that LED can be used as an indicator in the AC circuit by wiring it in an inverse parallel with normal diodes, as you can see in this figure. LED displays are available in many different sizes and shapes. The light emitting region is available in lengths from 2.5 to 25 mm. They are usually switched on and off by transistor circuits. Now let's move to the types of LEDs. As you can see in this diagram, you can see different kinds of LEDs. They are varying in shapes and sizes. Mostly these plastic lenses are taken of the same color as the actual color of the light emitted. The color of these plastic lenses that you can see over these LED lights, so these plastic lenses is often the same as the actual color of the light emitted. Its types are inorganic LEDs, organic LEDs, miniatures, that are these small LEDs, multicolor LEDs, that too in the bicolors or tricolors, etc., and the high power LEDs. Additionally, there are two more types of LEDs which are based on the structure of the LEDs, and that is surface emitted LED and edge emitted LEDs. Applications of the LED. So as we already know, LED emits visible as well as the invisible lights. So LEDs that emit visible lights are used in instruments as indicators, digital watches, picture phones, digital computers, and in calculators, multimeters, telephones, etc. And LEDs that emit invisible infrared lights in remotes, object detectors, traffic signals, burglars alarm system, etc. Its more applications are, you can see LED signals in indicators, in camera flashes, in lamps, lightnings, etc. Now as we know, each device has its advantages and disadvantages. So let's talk about the advantages of the LED. Talking about the temperature range. So its operating range is found as a wide range from 0 degrees Celsius to minus 70 degrees Celsius. In that low degree Celsius, LED can easily work. It is a low power consumption device. A very low power is needed to glow an LED. And it has a better control. How? We can control the intensity of light just by changing the current. We can change the intensity of the light. Moreover, it is economical and reliable, means it is cheap in price and has high degree of reliability. Another advantage is that it is a miniature in size and therefore can occupy small areas and hence are light in weight and have longer lifetime. LEDs can emit different colors of light like red, yellow, green, etc. This doesn't need any heating or warm up time. That's why it is used as an indicators. This is so quick in responding. LEDs do not contain toxic materials like mercury, which is used in fluorescent lamps. Therefore, it obviously had overcome the fluorescent lamps. They need moderated power. They are used where low DC power is available. These were the advantages. Now heading towards the disadvantages of LEDs. Over voltage and over current. Obviously, it may destroy the LED. So there is a possibility of loss when the power exceeds a certain limit. As we have seen in the advantages, LEDs work on the low voltage. So if we exceed certain limit, we may lose LED. The same is possible even when the power is low. The second disadvantage is the overheating due to the radiant power. It heats up with an excess increase in radiant power. This can damage the LED. Obviously, overheating may destroy any device. The device is known to have much wider bandwidth. As you can see the band gap between the conduction band and the valence band. So this device has much wider bandwidth. And the temperature depends on the radiant output hour and wavelength. One more disadvantage is we need more power to operate LEDs than normal PN junction diode needs. These were the disadvantages. Now ending this video with the conclusion. So LED lights are one of the latest invention of the scientists for reducing the negative effects of conventional bulbs to the environment. It is said to be safer and healthier light. Residential and especially commercial and industrial plants, stores, libraries, galleries and warehouses can immediately benefit from LED lighting. Studies reveal that LED bulb produces less carbon than older bulbs, which can be very useful to get rid of ill effects of global warming. So that's it in today's video of LED. Hope you found this video productive. Thanks for giving your time here. Take care.